Hello class, we are on we're going to start a lecture on confounding. With the confounding, we are also going to see what the meaning of effect modification. When you say something is an effect modifier, what's the meaning? Something is a confounder, what's the meaning? So that later within this week we'll also do a lecture on bias, then finish off with testing for associations. So without much ado, let's go to classroom and start our today's lecture. Thank you. Confounding. So, what is confounding? Something is confounding my mind, meaning that something is what? Confusing me. Confounding means what? Something that causes confusion. A confusionist. Something that causes confusion or a distortion. A distortion of any association of an association. So a confounder in our own in the worldly circles, we can say a confounder is an example of a gossip or a confusionist. A gossip. So a gossip will be okay for now. Confounder, a gossip brings confusion and distortion of association or friendship. So let's zero in. So confounding is the distortion of the association between an exposure and a health outcome by an extraneous or outside or a third party or a third variable. So if you have, this is me, this is myself, this is my wife, my lovely beautiful wife. So this is Ben, this is my wife. So I don't have a girlfriend but let me use my girlfriend. So a confounder will be what? Girlfriend. Okay, so this is girlfriend. So the girlfriend has association between me and my wife. So the girlfriend will bring confusion between myself and my wife. So the expectation of taking care of the children, providing for the house, there will always be confusion between myself and my wife because of what? A girlfriend. Because I can't give my wife the needed attention that she needs because of my girlfriend. So the girlfriend or a gossip is a confounder. So a confounder is a variable that is associated or has a relationship with both the exposure, that is myself and my wife, or exposure and the outcome. Exposure is the risk factor and the outcome is the disease or the effect. So systematic error. So what does a confounder do? The confounder does not decrease with increasing sample size, meaning that, you know, in statistics, whenever you increase sample size, you increase sample size so that you can get correct results or better, good associations, strong associations, so that you can make informed judgments or conclusions. But in case you have a confounder, even if you increase the sample size, your results is not valid because the confounder is bringing confusion. The more you increase the sample size, the more you increase the confounder or the confounding effect. So if you have a results or you are doing an experiment and you realize that the results you are getting is so bad, it's unexpected, so you increase the sample size. The more you increase the sample size, the result becomes bad, badder, baddest, and worse. So confounding does not decrease with increasing sample size. So examples are selection bias, information bias, confounding. So when you increase sample size, confounding will not decrease. When you increase sample size, information bias will not decrease. When you increase sample size, selection bias will not decrease. So our next lecture will be on bias after we've tackled the confounding. So whenever, as a scientist, you have to really know what a confounding is, what a bias is. It's very important. These two troublesome factors are very disturbing to all scientists. So, for instance, let's look at confounding, alcohol use and lung cancer. An example of a possible confounding is found in the relationship between alcohol use and lung cancer. So let's see, how does alcohol use affect or cause lung cancer? It does not make clinical sense to say drinking alcohol causes cancer. No. However, the confounding variable, which is smoking, whenever it is introduced, the relationship makes more sense. Yes, so when you introduce smoking, an individual who drinks alcohol is more likely to smoke. So that is why we say that those who are drinking alcohol get lung cancer, because they are also likely to smoke, and the smoking is the confounding factor here. It is what is causing the lung cancer, but not the alcohol. So the confounder is the smoking. So the variable is related to alcohol use and lung cancer, and is part of the causal pathway. So let's see. So for instance, if you have cigarette here, and we have exposure, which is alcohol use, which is the risk factor, and the disease, which is the outcome or the lung cancer. Like I said, whenever you see outcome is a disease, whenever you see exposure is the risk factor, and whenever you see confounder, that's the gossip or the girlfriend. So the confounder has relationship with alcohol use, which is the exposure, and the lung cancer, which is the outcome. But the confounder cannot come between alcohol use and lung cancer. Confounder cannot be on this causal pathway from alcohol use to lung cancer. But the confounder is only associated with the alcohol use and at the same time the outcome or the lung cancer. But it doesn't travel from alcohol use or cause alcohol use to increase lung cancer in the causal pathway. This green arrow is the causal pathway. Confounder does not have any effect here. But it will come and gossip to alcohol use and come and gossip to lung cancer, and spoil their mind and give wrong results. So how do we assess confounding? Thus, each potential confounder has to meet two criteria before they can become confounders. Criteria 1 is that the potential confounder must be a known risk factor for the health outcome or disease. So you cannot have a confounder that is not related to the disease. Yes, cigarette smoking, alcohol smoking, alcohol drinking is related to cigarette. Alcohol smoking, alcohol drinking is related to what? Lung cancer. Cigarette is also related to lung cancer. But you cannot say that alcohol drinking is causing lung cancer. Then you go and bring drinking malt or tea also causes lung cancer. They are not related. You pick risk factors that are related. Tea or Malta Guinness cannot cause lung cancer. We all know it. So if you go and pick tea or Malta Guinness, that Malta Guinness, tea, Fanta are risk factors, and they influence alcohol to cause lung cancer. Everybody will say you are out of your mind, because it's only the confounder should be something that is related to alcohol, and that is what every smoker will definitely drink alcohol. So the alcohol intake, we are saying it causes lung cancer, but what is the main confounder there, or the main risk factor that is making it cause lung cancer is the smoking. Alcohol alone cannot cause lung cancer. If the alcohol cannot cause lung cancer, it's the smoking. So that's the lacking variable. So broadly speaking, a risk factor is any variable that is already known to be causally related to the health outcome or disease, though not necessarily a direct cause. It is also an antecedent to the health outcome, or something that is related to the health outcome. It's related to lung cancer on the basis of scientific knowledge or theory, because we all know it's a fact that smoking and alcohol drinking are related, and that if smoking can cause lung cancer, the alcohol drinking can also cause. But the main cause is the smoking, which is a confounder. So criteria 2 is that the potential confounder must be associated with the main exposure, but not as a result of the exposure. So the exposure, which is alcohol drinking and smoking, are related, because every smoker will drink and every drinker will smoke. So they should be related. In other words, all potential confounders should be working independently and not as part of the proposed exposure health outcome. So all the confounders, they should work with the exposure to cause this. But the smoking cannot be here and lead to lung cancer. It should be associated with the alcohol use, associated with the lung cancer, but it cannot come in between them on the causal pathway, which is this green arrow. So properties of a confounder. Properties of a confounder. A confounder must be associated with the exposure, like I've explained. A confounder must be associated with the outcome, like I've explained, the disease. A confounder should not be a consequence of the exposure. It shouldn't be in the causal pathway, not caused by the exposure of interest. So it shouldn't be in the causal pathway. Confounding should be of concern under the following conditions: when we are evaluating an exposure health outcome, when we are quantifying the degree of association between an exposure and a health outcome. So, for example, you might want to quantify how being overweight increases the risk of cardiovascular disease. So, if you were concerned about age as a confounder, you control for the effect of age in your statistical model. So, overweight leading to cardiovascular disease. We should know that it's not only overweight, because we have children or even teenage girls who are very, very fat and obese. They are overweight, but they don't have cardiovascular disease. They don't have hypertension. They don't have heart attack. They don't have myocardial infarction, coronary artery disease. They don't have it. So we can say that if you are saying that the overweight is increasing cardiovascular disease, then there should be a lurking variable or an extraneous variable or a gossip variable, or there should be a variable that is causing gossiping, that is causing influencing the overweight and the disease or the outcome, so that the outcome will be realized. So that is age, because we know that if you are obese, you are overweight, and you are also a grown up, you are more highly or likely to have cardiovascular disease, heart diseases, because heart diseases are associated with what? Aging. So if a young child, a young boy or girl, very, very fat, may not necessarily have a cardiovascular disease. But if you are growing up 30 years, 35 years, 40 years, and you are fat, they say control your weight. Because if you don't control your weight, the more you age, the more you get the cardiovascular disease. So the aging is the confounding factor or variable that will predispose an overweight person to cardiovascular disease. So the aging is the hiding or lacking variable, extraneous variable that predisposes to cardiovascular disease. So that's the confounder. Aspects of confounding. So when we are looking at this genetic syndrome, which is called genetic syndrome called Down syndrome, initially they were thinking that this is birth order. Women with one child, women giving birth to the second child, women giving birth to the third child, women giving birth to the fourth child, the fifth child. They were saying that when you give birth in succession, like first child, you are not really at risk of getting giving birth to a baby which is having Down syndrome. But the second child, the risk is high. That is on the vertical axis. Third child, the chances of getting a Down syndrome child is high. Fourth child, fifth child. But what has birth order gotten to do with the risk of giving birth to a Down syndrome baby, or baby having Down syndrome? Because there should be something that is better explaining this fact. So, confounding. So, if you have many children, it puts you at a higher risk of getting or giving birth to children who are Down syndrome, who are mentally retarded. Why? So they are saying that a confounding variable over here is what? Maternal age. Maternal age is associated with the number of children and the outcome or Down syndrome. So the second, third, and fourth child are more often affected by Down syndrome. So why is it that the second child, third child, fourth child, fifth child they are at a higher risk of developing Down syndrome? Why do we explain this? So we bring a confounder, which is a maternal age, to see whether the maternal age is the actual cause of the Down syndrome or having many children is the cause. So let's see. So the Down syndrome, when we stratified it using different age groups, less than 20, 20 to 24, 25 to 29, 30 to 34, then these are the risks of giving birth to baby which is having Down syndrome or mentally retarded. We see over here. So we have considered the first one. We considered birth order. So now we go back to consider age, because we saw that age can be a confounder. So let's go and find out whether age is what is causing the Down syndrome. The age of the mother is what is causing the Down syndrome, or the multiple children, the number of children, that is what is causing. We want to investigate and find out why. So when we took the birth order, that's first child, second child, third child is at risk, fourth child is at risk, but first child is not at risk. So we saw over here that you can see looking at the birth order, it's not really affected. The birth order is not really affected. Look at it. 1, 2, 3. Look at their level. They are not high. The green is not so high. Even the fifth one is very down. But when you look at the age, 25 to 29, 35 to, so we realize that as the age increase, you can see it's increasing in height. The columns are increasing in height as the age increases. So 35 is here, then 39 to 40 whatever is here, then 50 to something is the red. You can see that the risk is increasing per age. So it's not the birth order, but it's rather the age that is causing the confounding influence. So we come back over here to see that, example, a Norwegian comedian once said, it's called Mavi Flexness. He once said, that I'm probably allergic to leather because every time I go to bed with my shoes on, I wake up with a headache the next morning. This is a man who always, whenever he went to bed wearing his shoes, relied on his bed with his shoes. He wakes up with the head aching him. So he realized that, hey, when I wear my shoes and sleep, my head aches me. So what is causing this headache? But will a normal person in the normal frame of mind sleep with the shoes on? Everybody will move the shoe. So he is thinking that maybe wearing the shoe tightens the blood vessels around his feet so that it causes him to have headache. But forgetting that this man, any person who goes to bed with the shoes on, it means that the person was drunk. Probably the person was drunk before going to bed, so he was so tired and weak and just fell on bed and slept. So it's the alcohol that is causing this man to have the headache, but not sleeping with shoes on. So the confounder over here, sleeping with shoes on, has been implicated in headache, with headache, but it has been implicated wrongly. The actual gossip or the cause is the girlfriend, the alcohol, which is causing the headache. So that's the confounding variable, alcohol. How do we control for confounding? Before we collect data, before we have in our minds that we are going to carry out a study, we can only control for confounding before data collection by randomization. That is, we are going to pick our participants at random. We will not say that, hey, we will not have any preference. Out of 100 female and 100 male, we will pick as and when we need to pick. So we will ballot and pick at random. That is what you call randomization. We will not show any favoritism. We will not take the beautiful girls to our group and select them before we select the ugly girls. No, we don't. We just do randomization. We just choose at random. Whether you are beautiful or you are ugly, we choose you based on merit, based on you are qualified or not. Then the restriction, we restrict entry to study of individuals with confounding. So if we suspect that you are a confounder, like previously we saw in the alcohol, wearing shoes and headache. So anything, so here with this man, if you are carrying out the research on this man, we'll make sure that we'll restrict him from taking any drink which contains alcohol. So anybody who has taken alcohol or drink that contains alcohol, we restrict the person from the study, and that is what we call restriction. But this one leads to what? Restriction leads to what? Reduction of sample size, because we don't even have the people to carry out the research in depth, and we are saying that we are preventing people who have taken alcohol from joining this study. Then we will end up with a very low sample size, which is not good for our statistical conclusions. We have something also we call matching, and matching is we match individuals or groups, aim for equal distribution of confounders. So for instance, if we have over here, if we have we want to control for confounding, so we do matching. So if we have 100 nurses, 100 nurses, 100 nurses, and we are going to carry out a research on 100 nurses. So versus 100 nurses versus so if you say we are matching them on so 100 nurses, so if you are matching the 100 nurses, so we have 100 nurses versus 100 nurses. So these 100 nurses, maybe these ones are females. We want to carry a research on them. So females and male nurses, which are 100. If you carry out a study on these nurses, we make sure that we match them. So if you are picking 100 nurses, we should make sure that they are within the same age category. So 20 to 25 years. 20 to 25 years old. 100 nurses who are 20 to 25 years old. Here too should be 20 male, so 20 to 25 years old. So we cannot pick nurses who are 20 to 25 years females and compare them with male nurses who are 10, okay, let's say 20 to 22 years, or let's say 18. We can't pick nurses who are younger for the male, so we cannot pick 15 to 20 years. 20 years. It's not good, because the characteristics of the age at the 20 to 25 years will be different from the characteristics between the 15 to 20 years, because 15 to 20 years is much more younger than so this association is cancelled, but this one is much more younger than this, but they should be of the same age. So this is correct. This association is correct. So here, if maybe, so we match with the same age. So age is a confounder, because age over here is a confounder. Younger age, older age. So the age will cause the results to be abnormal. But if we match them 20 to 25 years, 20 to 25 years, then that means that we have equally distributed the age between the females and the males. So age will not bias the results. That is the meaning of matching. Okay, so let's go to, after data collection, if already we have introduced confounding into the sample collection, and we have run our test and we have our data already, how do we make sure that we remove confounding from our data so that it will not bias our results? One is by stratification, which by confounders are distributed evenly within each stratum. I'll go and explain that, so hold on with that. Adjustment, usually distorted by choice of standard. Multivariate analysis only works if you can identify. So we are now going to tackle them one by one. We are going to start with the stratification. We will get there. So restriction is further explained, like I said, restriction of the study or the analysis to a subgroup that is homogeneous for the possible confounder. And initially I said that if you restrict alcoholics and others, it will end up giving you what? A limited or a small sample size. And we even need more participants. People don't want to partake of the research because the incentive you are giving them is too small. And they have ethical ramifications, because they are not ready to participate, because some of them are even afraid to draw for you to take their blood sample. They don't know what you are going to do with their blood sample. So if you are restricting people who have taken alcohol, then how many participants do you even have to carry out the research, and you are restricting? So this one will end to limited or small sample size. But the matching is what I just explained: selection of controls to identical controls to be identical to the cases with respect to distribution of one or more potential confounders. And like I said, the potential confounders is the age over here. Confounder can be another thing later, but over here I'm using age as a confounder. Okay, so why do we match? Random sample from source population may not be possible. So that is why we match. We match for quick and easy way to get controls. So these are the quick and easy ways to get controls. We can match on social factors, like we can pick the friends of the participants, or family members of the participants, neighborhood controls. We can also match on time. We can also improve efficiency of study, and the matching will improve the efficiency of study and can control for confounding due to factors that are difficult to measure. So matching can improve efficiency of the study to help us to get correct results, and can control for matching can control for confounding due to factors that are difficult to measure. Okay, so disadvantages of matching. Why is it that we should not match? What is the disadvantages of matching? It breaks the rule. The control group should be representative of source population. Therefore, if the control group is not representative of source population, then the matching will be wrong. For instance, in special match analysis, yes, for instance, you cannot study whether match factor has a causal effect. More difficult to. Okay, so with the first one, control group should be if the control group is not representative of the source population. For instance, you are looking at nurses, and you are going to bring hairdressers. How can you compare hairdressers and nurses? The control group should be representative of the source population. So if you have your cases to be nurses, and you go and bring controls as farmers and nurses have nothing in common. Hairdressers and nurses have nothing in common. So you end up biasing your results. So make sure that you pick controls that are related to the cases. You cannot study whether match factor has a causal effect. More difficult to find controls. Okay, stratified analysis. So, like I said, at the analysis stage, we have something we call stratification. In order to avoid or control for confounding, to eliminate confounding, you need to stratify. When you have all your data sets, you can now stratify during your statistical analysis. So let's go and see stratification. So with the stratification, you calculate crude odds ratio with whole data set. Then divide data set in strata for the potential confounding variable and analyze this separately. Calculate adjusted odds ratio. So when you finish, if the crude odds ratio, the difference between the crude odds ratio and the adjusted odds ratio is greater than 10 to 20%, it means that the adjusted odds ratio should be reported because confounding is present. So let's see in the next examples. So we can also control for confounding using multivariate regression. That's analyze the data in a statistical model that includes both the presumed cause and the possible confounders. Measure the odds ratio for each of the exposures independent from the others. Logistic regression is the most common model in epidemiology. Last time I showed you what logistic regression is. So logistic regression has multiple regression, multiple covariates, and we use it to adjust for confounding. We will see examples very soon. Then we will also be looking at effect modification. Effect modification before we look at the examples. So let me explain effect. When we say an effect modifier, it describes the situation where the magnitude of the effect of an exposure variable on an outcome variable differs depending on a third variable. For instance, effect modification happens when an exposure or treatment has a different effect and leads to a different outcome among different subgroups or strata. In other words, The presence of an effect modifier changes the association of exposure with the outcome of interest. So the effect modifier can be sex, age, an environmental exposure, or a genetic factor. Let me go explain. For example, the effect of smoking on disease outcome, which is lung cancer, it varies for different ages. For instance, the effect of smoking on lung cancer is different for different age groups. For instance, the effect of smoking on lung cancer, when you smoke, you get lung cancer. But children, the youth, when they smoke, they don't get lung cancer immediately, like those who are 40 years and 70 years. At 70 years, your immune system is compromised. When you smoke, you are even at risk of hypertension. And at 70 years, you are smoking. When you smoke at 70 years, you have a high likelihood of getting lung cancer compared to somebody who smokes at 20 years. Because 20 years hasn't gotten any correlation with age. With the immune system is so strong at 20 years. So you see young guys going about smoking. They don't see the effect now, but let them be growing. When they get to 35 years, 40 years, they smoke and they get lung cancer. Because at the youthful age of 20, their body is very strong. Their organs are new and vital. So their immune system is so strong. Their physiology is so strong. Their enzymes are so strong. Everything is good for them. But as you age, your organs deteriorate. Your immune system is compromised. Your strength goes down, and you are taking in and you smoke at this level, meaning that you are killing yourself. So you are killing yourself because your body, even your strength is going down, and you are adding an adversary or an enemy, which is the cigarette. This one will prolong, will hasten you getting lung cancer. So it's no good. So we say the effect modifier here is age. We all know that smoking causes lung cancer, but what increases the speed or the severity of the lung cancer is age. Everybody can smoke and get lung cancer, but you get lung cancer faster when you are aged, or as you age. You get lung cancer faster because your strength is down, your immune system is down, everything is down, your physiological setup, enzymes are in deficient concentrations. So age is over here is an effect modifier. It modifies the effect. It increases the overall outcome of a research. So the age will increase the outcome, that is lung cancer. So it's an effect modifier. So let me explain something over here. So if you are having age, initially, if the odds ratio for smoking on lung cancer, if the odds ratio initially is equal to 2 or 2.4, then at age 20, then the odds ratio will increase to what? 5. I'm just giving my example though. At age 40, at 40 years. So when you smoke at 40 years, your risk of getting lung cancer will increase to fivefold, from 2.4 to 5. Then at age Age 70, you are killing yourself. You are old, you've gone on retirement and you are smoking. Age 70, let me put 30 there. The odds ratio, the odds of you getting lung cancer will be 30-fold. Because you are closer to your grave and you are doing things that will make you die so fast. So 30-fold. So smoking is an enemy. It causes lung cancer. But the effect modifier over here is what? Age. When we go to the confounding, age was what? A confounder. But here age is not playing the role of a confounder. It's playing the role of an effect modifier, increasing the likelihood of what? An outcome. So two aspects to consider. Confounding distorts an association because it is a gossip. It distorts effect. But effect modifiers are useful because they increase the effect of analysis. So let's look at how we stratify, we control for confounding using stratification. Oral contraceptives and myocardial infarction, are they related? Women who take in Posnol 2, progesterone, estrogen, we call them secure. Those secure oral contraceptives, they're pills. Do those women get heart attack or myocardial infarction? Let's find out in a case control study. So the crude odds ratio, we are going to calculate the crude using this crude data. Crude means old. Crude means old or fresh data. We haven't done anything to it. So the oral contraceptives and myocardial infarction. Let's see how it correlates. Is there a relationship? So the women with oral contraceptives, 693 of them out of 1,000 had myocardial infarction. So the contraceptives these women are taking now is giving them heart attack. We will find out very soon. Then those who did not take the contraceptives, those women who did not take oral contraceptives, out of 1,000, only 307 of them had myocardial infarction, meaning that these women did not take in oral contraceptives, but maybe they were living a sedentary life, they were taking a lot of egg, a lot of fat, and they had what? Myocardial infarction. But those who took the contraceptives, 693 of them had myocardial infarction. Meaning that contraceptives is a very, very family planning. We should stop family planning. No, we have to find out, investigate it more. And the controls also. Those who took in the contraceptives who had myocardial, the controls. These are the controls that we have. So with the controls, 320 took in the contraceptives, and 680 is not taking the contraceptives. But they didn't have the disease, but it's the cases that have the disease. So let's see the odds ratio. Like I said, the over time you multiply diagonally. So 693 times 680 divided by 307 times 320 will give us 4.8, or 693 divided by 307, or divided by 320 divided by 680. So odds ratio 693 times 680 times 307 times 320. Let me take it again. Odds ratio 693 divided by 307, that's it. 693 divided by 307. 320 divided by 680, that's it. It gives us 480. It gives us odds ratio of 4.8. So these women who took in, so we conclude by saying that women who took in oral contraceptives had a 5, we approximate this to what? 5. So they had 5-fold increase odds of having myocardial infarction. So let's see. So, but how can oral contraceptives? Oral contraceptives was giving a 5-fold increase in the odds of myocardial infarction. Then almost everybody, or every woman will be having a heart attack now. So let us find out whether there is a confounder over here. So we come here, smoking. Okay, there are some of the women who smoke in addition. They take in the contraceptives and they still smoke. Others still take in the contraceptives, they don't smoke. So those who took in the contraceptives and they smoke, 517 times 340 divided by 183 times 160 gives us an odds ratio of 6. Non-smokers, women who don't smoke but take in oral contraceptives over here, their risk of getting myocardial infarction is 3. So meaning that smoking is what is causing the myocardial infarction, but not the oral contraceptives. If it were like that, all our wives would have died by now. But you are taking contraceptives and you are smoking at the same time. You have high likelihood, because smoking leads to lung cancer and it also leads to hypertension because of muscarinic and also nicotinic receptors are increased, and the smoking, this thing, active ingredient binds to muscarinic and acetylcholine binds to the muscarinic and nicotinic receptors, increasing hypertension. And so smoking causes hypertension. So the confounder over here is the smoking. So we can say that the women who take oral contraceptives, they don't have any myocardial infarction, but the lurking variable or the extraneous variable or the hidden or the gossip is the one that is causing the myocardial infarction. So let's continue. So what do those two different odds ratio mean? Taking oral contraceptives is a risk factor for myocardial infarction, especially in people that smoke. That is true. But if you don't smoke, oral contraceptives will not be a risk factor for you. So among smokers, the odds of finding someone who takes oral contraceptives among the cases is 6 times the odds of finding someone taking oral contraceptives among the controls. Likewise, among the non-smokers, finding someone who takes oral contraceptives among the cases is only 3 times the odds of finding someone taking oral contraceptives among the controls. So we saw it here. Smokers with oral contraceptives 6 times or 6-fold. Non-smokers oral contraceptives 3-fold. So when we say crude oil ratio of 4.8, so let's say in the numeric analysis, that is if you are using the stratification. So we had what stratum specific odds ratio for 6 and stratum specific odds ratio for 3. So if two subgroups have different odds ratio, there is effect modification or interaction. So because smoking is now increasing the effect over here, smoking is increasing the effect. It's not the oral contraceptive that increase the likelihood of getting myocardial infarction, is the smoking. So smoking, when you subtract 3 from 6, you get what? 3. So it's even above 20%. So when you subtract 3 from 6, you can see that the stratum specific odds ratio for smokers is higher, meaning that smoking is an effect modifier. It's increasing the likelihood of getting the disease. So if effect modification is present, always show stratum specific odds ratio in order to be able to direct control measures. Okay, so let's see examples of effect modification. Hypertension is more likely to cause myocardial infarction in people with hypercholesterolemia. We all know that hypertension causes heart attack or myocardial infarction. It is a fact. But the myocardial infarction, the hypertension is the likelihood of causing the myocardial infarction is by the hypercholesterolemia, high cholesterol level in the blood. Because if you have high cholesterol level in the blood, your likelihood of getting myocardial infarction is faster and severe than somebody who does not have high cholesterol level in the blood. So hypertension is more likely to cause myocardial infarction when the effect modifier is high cholesterol level, because cholesterol will rather increase your risk of getting myocardial infarction. We all know that malaria can kill, but it is more serious in pregnant women. So we say the effect modifier over here is the pregnant women. If it is not pregnant women, it's just young men, they will recover because their immune system is strong. But the pregnant woman's immune system is very weak. So we say that the effect modifier over here is the pregnant woman, because the pregnant woman is at higher risk or increases the risk of death for malaria. Measles causes more deaths in malnourished children. A normal child can get measles, but it will not lead to his death. But if measles attacks a malnourished child who does not eat well or doesn't have all the balanced nutrients, then measles will outweigh its defensive mechanism or immune system, and measles will kill him, because measles will come and the malnutrition will complicate the measles, and so the malnutrition is the effect modifier over here. So looking at effect modifiers, they are different from confounders. Effect modifiers increase the likelihood of getting a condition or an outcome, whereas confounders rather confuse or distort the outcome. It doesn't give us the actual presentation, it biases the results. So for effect modifiers, the first example, we have hypercholesterolemia as the effect modifier, then pregnant women as effect modifier, then malnutrition or malnourished child as an effect modifier, because it increases the risk or likelihood of getting a condition. Okay, so let's come back to confounding. So alternative explanation, we finished with effect modification, so let's see confounding. Alternative explanation for an association found between an exposure and an outcome is confounding. So let me also give you one more example of a confounder. So you cannot say okay, so can you say that salt causes hypertension? Salt causes hypertension. Salt intake. That's we are looking at confounder again. Salt intake leads to what? Hypertension. Salt intake leads to hypertension. Hypertension is a stiffening of the blood vessels or pressure in the blood vessels, and the heart pumps against pressure, resistance. Salt intake leads to hypertension. But everybody takes salt. Babies take salt. Children take salt. It doesn't give them hypertension. So why do we say that salt intake gives hypertension? So over here, age will become an effect modifier. So age will modify the effect of getting hypertension. So age is like this. So salt intake plus age will lead to hypertension. So salt intake plus age will lead to what? Hypertension. This is effect modification. Okay, so let's also look at confounding. Salt intake causes what? Hypertension. Salt intake leads to or causes hypertension. But the confounding variable over here associates with what? The age. So age is the confounding variable. It associates with salt intake. It also associates with hypertension. So we don't know which is which. Whether age is together age plus hypertension, age plus salt intake giving us hypertension, or age plus hypertension giving us the salt intake. We don't know. So the confounding causes confusion. But the estimate, the effect modification, right?